Hello, 8th graders. Your video for tomorrow is going to be on section 1.7 out of the book, and it is covering distance in the coordinate plane. There are quite a few terms that we need to go over first, and a lot of these should sound familiar. We talked about them before. First of all, the coordinate plane, that's a grid formed by the intersection of two number lines. So that's where we graph things. We've used it a bunch of times. The y-axis is the vertical number line, so the one that goes up and down. The x-axis is the horizontal number line, goes straight across. And I'm going to draw this out here in a minute, but I'm just going to go through these real quick. Quadrants. So when you have your x and your y-axis and they cross each other, it divides the plane into 4 parts, or 4 quadrants. And I'll show you how those are numbered here in a minute. The origin is right in the middle, right where the number lines meet. It's at point 0, 0. Ordered pair, the xy, it gives the coordinates of the location of the point. The x-coordinate always tells the number of horizontal units a point is from the origin, so how far left and right it's moving, and that will always be the first number in an ordered pair. So if I had the numbers 3, negative 3, 3 is always the x. The y-coordinate tells the number of vertical units, so up and down a point is from the origin. It's always the second number, so this number right here, the negative 3, would be the y, and that never changes. It's always xy. X comes before y in the alphabet, so that's how we do it here too. So here you have a coordinate plane. This is the x-axis. This is the y-axis. This right here in the middle is the origin. It's at point 0, 0, right where they meet. When you talk about quadrants, this is labeled as quadrant 1. This will be quadrant 2. It goes counterclockwise. This is quadrant 3. And this one is quadrant 4. We can use our information about the Pythagorean theorem to be able to figure out the distance between points on this coordinate plane. And we're going to do an example right now. So our example is, if we're going to find the distance between the pair of points, we're going to round to the 10th if we need to. Our points are 2, 2, and 6, 5. All right, so the first step is you're going to graph the points. So you need to make a little coordinate plane. We're going to go ahead and graph this. So 2, 2, 2 to the right and 2 up. And 6, 5 would be 6 to the right and 5 up. So right there. Okay, so that's step 1. Step 1 says graph the point. Step 2 says make points into a right triangle. So I'm going to connect this, and then I'm going to make a right triangle out of it so that I can use that. I wonder what we would use a right triangle, how we would figure that out. I'd be willing to bet we've done this many times with using the Pythagorean theorem. All right, so now that we have a right triangle, it says step 3, use the Pythagorean theorem to find the distance, which will be the hypotenuse, because from here from this point right here to this point right here, that is the longest side of this triangle. You can see here that the right angle is right here, so we know that across there is the hypotenuse. So it's C that we're looking for. And we can use this graph to help us find the lengths of the other two legs. So let's just say that this is A and this is B. It doesn't really matter, just that those are A and B. So A is 1, 2, 3, 4 long, and B is 1, 2, 3. So I'm going to plug that into my theorem, and that's going to equal my C squared. So 4 squared is 16. 3 squared is 9. 16 plus 9 is 25. And then remember, our last step is always to square root. So our answer to C would be 5 units, whatever the unit might be. And that is how you use the Pythagorean theorem to find the distance between 2 points on a coordinate plane. Bring that knowledge and a positive attitude to class on Monday, and we'll talk about it then. Have a good weekend.